Functions. In this section of the notes, we're going to introduce you to the idea of a function. We use these a lot in algebra, and we'll be studying these in great detail when we get to chapter 2. A relation is our first definition, and that is simply a set of inputs and outputs. Typically denoted using an ordered pair, like xy, where x would be the input and y would be the output. Okay, so a relation is just a very general thing in algebra. It's just any set of inputs and outputs. A function is a little bit more specific. It is a relation in which each input has only one output. Okay, so what does that mean? Well, that means that each x is only associated with one y. If there was an x that was associated with more than one y, it would not be a function. Okay. So for instance, if I had a point in my relation 1, 2, and another point in my relation 1, 3, that would not be a function because the same input has two different outputs. And a function needs to have each input with its own output. Okay, so you could be a relation, but not be a function. However, all functions are relations. Now, when studying functions, one thing we'll be interested in is what can you use as the inputs and what do you get out as the outputs? And we have two special terms for that. The domain is all possible x values. So we're talking about what are the inputs in our relation or function, and the range is all possible y values, and these are the outputs. So when you're asked to find the domain and range, what we're really thinking about is what are the possible inputs I could have, that's my domain, and then what are the possible outputs I could have, and that's my range. So if you look at the following two examples, it says, are the following relations or functions? And then it's asking us, what is the domain and range? So looking at this first table, remember that the inputs are always our x values, and our outputs are always our y's. So if you look at this, you will notice that I have two inputs that are 1, and they go to different outputs. Well, that breaks our rule of a function in which each input can only have one output. So this would just be a relation. The domain of this would be the inputs. So it's pretty easy when you're looking at a table. The x's are the domain. So the domain would be 0 and 1. I would not list 1 twice there. The range would be the y's. In this case, 1, 2, and 5. In example 2, I have inputs, which I remember are x's, and outputs, which remember are y's. And if you look, I have 6 different inputs. Okay, so notice that none of the inputs repeat. Like in our first example, I had 2 of the same inputs. So this is going to be a function. Okay, I would need to have an input that repeats in order to even possibly break the function rule. Keep in mind, this is also a relation, but a function is a better description because it's more specific. Okay. The domain would be the numbers 1 through 6. So we could write 1 through 6. And the range, if you notice, all the y values are the same, so the range is 0. Okay. So a key thing when you're looking for trying to determine if something is a function or not is if you see repeating inputs that go to different outputs, it's not a function. Now, another way to show relations and functions are graphs. So you'll notice on the first example on the left, I have a graph. It's a curve. You'll notice that there are points on the curve, right? And if you look carefully, there are points that have the same x, like these two right here. The x of the top point is -1, and the y is a 1. And the bottom point, right here, the x is -1, and the y is -1. So I have two inputs that are going to different outputs. That makes this not a function, it's only a relation. Now, a very common and easy test to do on a graph to see if it's a function or not is called the vertical line test. Could abbreviate that, VLT, vertical line test. And all you have to do simply is draw a vertical line through your graph. If it hits the graph in two spots, there's no way that that could be a function. Now, for the domain, and we'll come back to vertical line test a little bit later. For the domain, I would like to know what x's were used to make this graph. Well, if you look carefully, the x's, there's no x's to the left of that little dashed blue line that I just drew in the picture. All the x's that we use start from -2 and go to the right. So one way we can say that is we can say that x is greater than or equal to -2. The range of this function is all the numbers that the y's could possibly be. And you may notice on this graph that there are two arrows. These arrows mean that the graph goes on forever. If I had a big enough paper, I could just keep extending this forever and ever. So it's going to keep going down forever, and it's going to keep going up forever. So the range of this is all real numbers. Like any number will work as the range. Now, looking at our second set of information, these are just 5 plotted points. You could use that vertical line test I was talking about earlier and see if is there any place you can draw a vertical line where it would hit 2 points. And I think you can see that right there, that vertical line hits 2 points, which means there are 2 points that have the same input, -2, but different outputs, 0 and -3. So that cannot be a function, so it is a relation. Now, the domains, since these are just points, all we would say are list out the x's. So -2, -1, 0, and 1. And the ranges would be the y values of all those points. So it would be 0, this one's -3, this one's 1, this one's -2, and I have 1 again. Now, this next graph it looks like a V, okay, and has arrows, which means it goes on forever. If you look, is there anywhere I could draw a vertical line that would hit this graph twice? And if you look carefully, there really isn't. So this would be a function. It is also a relation, but a function is a more specific answer. Now, for the domains, the question is what x's are used in this picture? And because of the arrows, which means this graph goes on forever in both directions, every possible x will be used. Okay? One way to write that using inequalities is to say that x can be any number less than infinity and greater than negative infinity. So that just means that every possible x, any number, could be used as a domain. Now, the range is asking what y values can be used. Well, it doesn't look like this graph ever goes below -1. So it goes from -1 through as high as you possibly want on the y values. So you could say it goes from -1 to infinity. So we'd say y is greater than or equal to -1, less than or equal to infinity. Now our third picture, this is a circle, and I think you can see that this circle would fail that vertical line test. Any place I draw a vertical line here, I'm going to hit 2 points. So this is just a relation, not a function. The domain, if you look carefully, let's change colors here. The only x's that are used in this picture are in between those two red lines, which look like it's from -2 to +2. So the domain would be x greater than or equal to -2 and less than or equal to 2. Now I'd use those equal signs under those symbols because there is a point at that spot. Now if you look at the range, I'll change colors. The range is what y values are used. And it looks like basically the same values. The smallest y is -2, the biggest y is +2. So I could write that as y is greater than or equal to -2, less than or equal to +2. Our last example, this is called a parabola. If you look at it, you cannot draw a vertical line and hit 2 points of this parabola anywhere. So this would be a function. Remember, it is also a relation, but function is more specific. The domain is what x values could you use, and if you look carefully, this parabola has arrows on the end. It's going to keep going further and further to the right and left as it goes up. So the domain is any number, and one way we can say that is that it's less than infinity and greater than -infinity. In some books they say all real numbers. And the range, if you look, this graph never drops below -4. So that means the lowest y is -4 and the highest y is infinity. One thing I'd like to add to our notes here at the bottom is just give you a definition of the vertical line test, which is a great way to determine if a graph is a function. And basically, the vertical line test says if a vertical line touches a graph in 2 or more places, the graph is not a function. Okay. If a vertical line touches a graph in 2 or more places, the graph is not a function. Good luck with your function homework.